Okay, real talk. Pick any number. 12, 100, 8,633, doesn't matter. What if I told you every single one of them is secretly built from the same tiny set of ingredients, like Lego? And once you can see those ingredients, finding HCF and LCM, the stuff that usually makes people groan, becomes almost stupidly easy. Stick with me for a few minutes and I promise, this clicks. Here's the big picture. Today we're looking at the building blocks of numbers. Primes. We'll see how every number breaks down into primes in exactly one way, then use that single idea to crack HCF and LCM with no rules to memorize. Think recipes. If you know the exact ingredients in two dishes, you instantly know what they share and what it takes to make both. That's all HCF and LCM really are. Let's meet the ingredients. A prime number has only two factors, 1 and itself. 2, 3, 5, 7, 11. They're the atoms of the number world. You just can't break them down any further. Every other number is what we call a composite. And that just means a number that isn't prime. Numbers like 4, 6, 8, 9, the ones you can build by multiplying smaller numbers together. Composites are just primes stuck together. Take 60. Let's pull it apart. 60 is 2 times 30. 30 is 2 times 15. 15 is 3 times 5. And now everything's prime. We can't go further. So 60 is 2 times 2 times 3 times 5. Or, writing the repeats as powers, 2 squared times 3 times 5. And here's the beautiful part. There is exactly one way to do this for every number. However you start breaking 60 down, you always land on the same primes. That's the Fundamental Theorem of Arithmetic, a fancy name for one simple idea. Every number has one unique prime fingerprint. Quick check. Now you try one I haven't done for you. What's the prime factorization of 72? A. 2 squared times 3 squared. B. 2 cubed times 3 squared. C. 2 cubed times 3, or D. 2 squared times 3 cubed. You have 10 seconds to solve this. Pause if you need more time. Okay, 72 is 2 times 36, 36 is 2 times 18, 18 is 2 times 9, and 9 is 3 times 3, so that's 3 2s and 2 3s. 2 cubed times 3 squared. That's option B. Now the payoff. HCF, highest common factor, which just means the biggest number that divides both numbers exactly. The slow way is to list every factor and hunt. The fast way uses the fingerprints. Let's do 12 and 18. 12 is 2 squared times 3. 18 is 2 times 3 squared. For the HCF, take only the primes they both have, each at its smallest power. They both have a 2. Smallest is 2 to the 1. They both have a 3. Smallest is 3 to the 1. Multiply 2 times 3 is 6. HCF is 6. The shared ingredients at the smaller amount. LCM, lowest common multiple, which just means the smallest number that both numbers divide into. Same fingerprints, opposite rule. Take every prime in either number, each at its highest power. For 12 and 18, the 2 appears, highest is 2 squared. The 3 appears, highest is 3 squared. Multiply, 4 times 9 is 36. LCM is 36. HCF is what they share at the minimum. LCM is everything between them, at the maximum. And a neat self-check. For any two numbers, HCF times LCM equals the product of the numbers. Watch, HCF was 6, LCM was 36. 6 times 36 is 216. And 12 times 18? Also 216, every single time. So if a question gives you the HCF and hides the LCM, you don't factorize again, you just divide. All right, your turn and this one's on you. Two numbers, 8 and 12, what's their LCM? A, 4, B, 12, C, 24, or D, 96. Drop your answer in the comments. A, B, C, or D. I read every single one. If this made primes finally feel useful, follow Clarix. We're doing the whole syllabus, chapter by chapter. And next video, we take this exact idea and use it to prove something wild, that the square root of 2 can never, ever be written as a fraction. Trust me, that's where it gets really interesting.